This week, we're going to talk about understanding your genes. Interesting topic. As we start to see more and more companies come out with gene therapies, gene information, as we start to understand how our genes play a role in eating habits, taste buds, disease, and other things that we need to pay attention to. It's more and more important that we understand what our genetic code is, what it's made up of, and most importantly, how it affects us. So let's kind of jump in. First, what is DNA? It's a history book, a narrative of the journey of our species through time. It's a shop manual with an incredibly detailed blueprint for the building of every human cell, and it's a transformative textbook of medicine with insights that will give healthcare providers immense new powers to treat, prevent, and cure disease. At least that's what Francis Collins said. The funny thing is, as we learn more and more about DNA, and as we learn more and more about ourselves, the interesting thing about his statement, and this, is going back to when we first started learning about this stuff, is that third paragraph. In the form that it's a transformative textbook of medicine with insights that will give healthcare providers immense new powers. What we're learning is it's just the opposite. It's actually taking powers away from healthcare providers because what used to be a treatment protocol determined based upon a doctor's best information, based upon objective and subjective information he was presented or she was presented with through biometric information and other testing procedures, genetics is now becoming the indicator of the treatment protocol. And because of that, because it's now statistical and now because it's, no longer theoretical, it's actually practical, what you end up with is the possibility in the very near future of you going to a doctor's office for a certain disease, just for instance, say cancer, and because of your genetic code or because of your DNA, your treatment protocol for that cancer will be determined not by a doctor or a team of doctors, but by a computer that takes into consideration your DNA sequence, the commonalities of your DNA sequence with all the other people in the world that have the same or similar DNA sequence with the type of cancer that you have, and then provides a treatment recommendation with the most likely probability of a positive outcome. That's where we're headed. So as insightful as this definition is, it's somewhat wrong in the sense that where we're really headed is taking away from doctors the information that they would typically use both objectively and subjectively to treat you and getting to more of a computer-based clinical approach, or at least that's where it seems things are headed. First and foremost, though, we need to understand what does DNA look like. And this is oversimplified, just so everyone knows. This is purely oversimplified. But you're talking about, thymine, adenine, guanine, cytosine. In there and holding them together is the deoxyribose or the sugar, and then the phosphates, and then of course the hydrogen bonds keeping everything connected. But that's in essence the simplistic explanation of everything that's involved with regard to what your DNA looks like. But what makes one gene different from another? Well, the DNA is the life instructions for the cell. That's kind of where it all starts. The gene, if you will, or the segment of the DNA that tells the cell how to make a certain protein. You can see here there's the three proteins. The proteins act alone or in complexes to perform, what the cellular function is going to be. And then, of course, the allele is one of two or more different versions of a gene and how they present themselves. So, the genes contain instructions for making proteins. That's how this thing works, is the genes produce the proteins that create the DNA sequence that, contain the chromosomes, and you become who you are. So that's kind of how all that fits together. But how we're using the human genome information is somewhat interesting. So first, we're understanding human disease better. Doctors, scientists, hospitals, practitioners, clinicians, and even research scientists are starting to get more and more genetic information so that they can understand human disease much better. For instance, we all know that we have cancer genes in our body. If you didn't, FYI, you do, because we all do. The question is, are they going to get turned on? are they going to present themselves? And there's different factors that could cause that to happen. Diet, lifestyle, environment are the three main functions of those. But we're learning more and more every day. The greater insight into cognitive function. There's a lot of information we are learning with regard to genetic predisposition to cognitive disorders, to dementia, and specifically to Alzheimer's, that increase our risk of contracting the disease, especially if we expose ourselves to certain diet, lifestyle, and environmental factors. So as we start to learn more and more, we are going to start attacking these types of cognitive diseases through a preventative approach rather than a reactive approach based upon the genetic code that you were born with. Unfortunately, you can't change your genetic code. We also have a lot of information with regard to insight into human origins and the evolution of the human mind and body, and especially how it has reacted over time to certain diseases and evolved with regard to its immune system to fight off those diseases. We've identified genetic susceptibility to disease. Everyone's heard of the predisposition to breast cancer, for instance, the BRCA1, BRCA2 gene. There's a lot of others out there as well with regard to diabetes and high blood pressure and asthma and the like. So we're learning more and more with regard to that on a daily basis. But one of the fastest growing areas there is when it comes to genetic information is what we call personalized medicine and personalized pharmacogenetics. Or another term that you can look up in Google is something called precision medicine. What this is going to lead to is exactly what I talked about a minute ago, which is now you have gone to the doctor and you have presented with a particular type of issue. Let's call it diabetes. Right now, everyone is basically under the same treatment protocol for the most part with regard to what's going to happen. In the very near future, though, what you may end up with is a genetic test. On the day you're born, you have a genetic test, and that genetic sequence, if your DNA sequence, will follow you around through your medical file the rest of your life. And you present with diabetes, and your doctor will know exactly what to do because the computer will tell him or her, based upon the genetic code that you have, this is the treatment protocol for this individual. They will then relay that to the compound pharmacologist, who at the pharmacy that you're going to go to is going to make a specific pharmacological drug made specifically for you that is designed based upon your individual needs. All of this should sound very familiar for the folks with ID Life because though we don't do the genetic component just yet, we do have a very customized vitamin platform that is made just for you based upon exactly what you need based upon the information you provide. Genetics is the natural progression of where everyone is headed, so that might be a little insight into the future of ID Life as well. Chronic illness has surpassed infection diseases as the top killer of humans. That's right. For the first time in history, chronic illness has surpassed infectious disease as the top killer of humans. There's a lot of reasons behind this. A lot of it is the toxins, pollutants, pesticides, food, chemicals, and, of course, cosmetics that we use on a regular basis. It's things that we're exposing ourselves to. It's things that we're consuming on a regular basis. Our diet, lifestyle, and environmental choices are killing us, literally. Unfortunately, they kill us very, very slowly. So gone is the day where viruses and bacteria are the main killers. Now what we're dealing with is the things that we are exposing ourselves to voluntarily and intentionally are causing our long-term chronic illnesses and diseases that are actually now killing us at a greater rate than anything else. Here's a prime example. China has a major air quality problem. Most people here in the U.S., hey, it's China, it's not us. Why do we care about China's air problem? Well, the reality is, if you didn't know, it only takes 5 days for the jet stream to carry that polluted air to the United States. Let's let that sit in for a second. See, everyone thinks, what's happening in other parts of the world doesn't affect us, doesn't have anything to do with us. We don't care. Why should we, really have any worry in the world with regard to the quality of China's air? I don't plan on going to China. I'll be fine. But the reality is the folks in California should care because this is affecting them. This is adversely affecting them. In fact, if you actually look at the information, the state with the most toxic tap water there is California. Now, see, what's interesting about this stat is you would think California has the cleanest drinking water. They have some of the most aggressive environmental laws on the planet. They are very progressive when it comes to the protection of the environment, as well as the utilization or use of all of any herbicides, pesticides, pollutants, toxins. They have more warnings. If you're not familiar with Prop 65, you should become familiar with it. I mean, they have more warnings on products than anything else out there. In fact, if you want to sell products in California, you have to put special warnings on your packaging. But the reality of what's happened is because of the Asian Peninsula and the environmental issues associated with the Asian Peninsula, California is one of the very first states to get affected by the waters, by the rains, by the air, and other things that come from those places. So as a result, they have this polluted tap water at a greater rate than anyone else. The average American is consuming 25 or uses 25 gallons of toxic chemicals in their home every year. That's right. So, you are being exposed. In fact, the average American is consuming about 18 pounds of these chemicals into their body every year. And you're like, well, hold on a second. I'm not eating. I'm not drinking. How in the world can I consume 18 pounds on average? Well, if you weren't aware, you actually ingest these through your skin. So a good set of rubber gloves would not be a bad idea the next time you get ready to clean your house. Avoid taking this stuff in through your skin because you are adding a lot of chemicals into your body on a regular basis. So, epigenetics. We've talked about genetic expression. We've talked about whether or not, we've talked about everyone having cancer genes and whether or not they're actually going to get turned on. It's interesting because when you have this type of conversation, a lot of times people are like, well, hold on, I don't have cancer. The reality is we all have it. They're all there, whether or not they're going to express themselves. So the way that works is you have your genes, and then you have your environment, and that results in genetic expression. Environment can include diet, lifestyle, and environment. So that's the way simplistically it works. But another way to understand it is when the genes and the environment combine in the wrong place, the wrong time, with your genetic sequence based upon the genetic lottery that you were given when you were born, that's when disease presents itself. Because your genetic sequence makes it so that you should avoid certain environments. So where are we in the future? In the future, we will learn enough information and have enough information to provide to you and everyone else, hey, you really shouldn't eat these things. You really should not expose yourselves to these things. You really should avoid these types of environments if you, in fact, have this genetic sequence. That's how sophisticated things are going to be very, very soon in the future. So what can it affect? It can affect everything. Eye toxicity to neurotoxicity to reproductive toxicity, respiratory toxicity. This affects everything. Our genes are such that if we expose ourselves to certain diet, lifestyle, and environmental choices, they will attack, they will affect, they will present themselves, or the genetic expression will present itself in different parts of the body. And that's why we need to better understand who we are, where we came from, and most importantly, what our genetic sequence is, so that we can better understand the choices that we're making and stop trying to fight ourselves on our own genetic code. Here is a prime example, methotetrahydrofolate reductase, also known as MTHFR. If you're not familiar with the term, all you have to do is put a hashtag in front of it and you will never forget it. Yeah, I know, a little crude, but hey, I'm trying to make a point here. I want everyone to know what this is. And the reason why is because it's the inability to uptake normal folic acid as a result of having a genetic polymorphism. It is not a genetic problem. It is not a genetic abnormality. Over 40% of the population has MTHFR. The reason why this is important is because it has been linked to the #1 cause of miscarriage in this country. So if you're a woman who's trying to get pregnant or is pregnant, you might want to consider a supplement of methylfolate as opposed to normal folic acid, because folic acid is necessary for the development of the spinal cord and spinal tube in a fetus. And one of the things that we have learned is that women that suffer with MTHFR have a high probability of miscarriage. So this is one of the places where this is being utilized and understood better. But there's men walking around with MTHFR as well, and the effect that it has on your body can be tremendous in all kinds of different areas. In fact, I got the genetic lottery myself, where I got the wonderful MTHFR from both sides of the parents. So I got what they call the double polymorphism. I got it from both sides. So guaranteed that my daughter has it at least from me. And I'm glad that we've learned something about what MTHFR is. And if you don't know what this is, by all means, Google it. There's tons of information, but the diseases and issues that are associated with it are pretty astounding that you need to know. But really, MTHFR is basically, if impaired, okay, that's the methylation process is impaired. It makes it tough for our body to fight off constant environmental toxic overload. So one of the things we're talking about is pollutants, toxins, pesticides, things like that. If you have MTHFR, you are not equipped biologically, genetically, to fight off these constant environmental toxins. That makes you susceptible to a lot of issues, problems, and diseases. But it's also going to exacerbate certain diseases as well, including ADHD, Alzheimer's, osteosclerosis, autoimmune disorders, autism, all kinds of things out there. And it's one of those things where if you have it, understand what you can do with it. But most importantly, the most important part about this is understanding that genetics can play a big role in our inability to get the results that we're looking for from our diet and lifestyle choices. So for instance, you may be a genetic code person where your best macronutrient breakdown is 40% carbs. That happens to be me. According to my genetic sequence, I need 40% carbs, 35% proteins, and 25% fats. That's my perfect macronutrient diet according to my genetic sequence. Well, what happens if I decide to go on the Atkins plan and I go no carb? Now I am literally fighting my body. That's in essence what I'm doing. I'm fighting my own genetic sequence. What kind of results am I going to get? Same can be said about MTHFR. If you have this polymorphism, by all means, understand what it is, understand what methylfolate is, and understand how to provide your body with the nutrients it needs so that you can get what it is you need to maintain your highest level of health. But MTHFR in pregnancy is probably the biggest area right now, and it's the one thing that people have focused on the most with regard to this particular disease. But 3 months before conception and during the first trimester of pregnancies, mothers who get enough folate lower their risk of miscarriage and child's risk of various health problems. The problem with MTHFR is you don't have the ability to uptake normal folic acid, so you need, instead of the typical prenatal or the typical folic acid supplement, you need something called methylfolate. And if you're trying to get pregnant or you are pregnant and you don't understand what this is and you don't know if you're MTHFR positive, I would highly recommend a supplementation with methylfolate out of an abundance of caution because of the increased risk. Having more folate in your diet means you're better able to create active form of 5-MTHF. Some of the best high folate foods, so if you're inclined and you want to get more MTHFR or the methylfolate into your body, these are the types of foods that you need to eat more of. So you don't have to just do it through supplementation. You can actually eat these things. Beans and lentils, leafy green vegetables, specifically dark green leafy vegetables, asparagus, romaine lettuce, broccoli, avocados, bright colored fruits such as oranges and mangoes. The problem with this list is that 75% of Americans do not get simply 5 servings of fruits and vegetables a day. But if you are somebody that has MTHFR, you might want to consider changing your diet so that you can maximize your intake and ability to uptake folic acid. And then, of course, those with the MTHFR mutation are also more likely to be low in related vitamins, including B6 and B12. A big push right now with people taking vitamin, B12 shots and things of that nature. The problem is we have now learned that there's also a polymorphism for the B12 vitamin where people can't uptake the normal cyanocobalamin or B12, and they need methylcobalamin there as well to be able to get the benefit of the B12 vitamins. So the last thing you want is, if you have that polymorphism, is to go in and intravenously get a B12 shot that you couldn't uptake if you took it orally. Now all you've done is intravenously put something in your body that you can't uptake, and you're going to get the adverse effects of that. So, how big of a deal is it? Genetics, do they really play a role? Well, it's all over the news. Genetics and disease is everywhere. I mean, from discovering the markers for stroke and cardiovascular disease to Alzheimer's disease and type 2 diabetes to, the genome-wide association studies that have been done on all kinds of different things, to the risk of prostate cancer, and of course, the cognitive disorders that we talked about earlier. You can literally Google your genetic code and find out that what's happening right now is people are learning sometimes unwittingly of their predisposition to certain diseases as a result of the genetic lottery that they were dealt. Here's the thing. My greatest fear in life is that I'm going to end up with Alzheimer's. This is me personally speaking, and that's my greatest fear. I went ahead and had my genes tested. I went ahead and determined that I was going to get the information to determine if I had the predisposition, because it was my greatest fear. And when I found out that I did not have the genetic predisposition, it was a relief. But guess what? It doesn't mean I'm not going to get Alzheimer's. All it means is I don't have a genetic predisposition that increases my risk. If I still do all of the things that are associated with an increased risk of contracting the disease, it doesn't mean I'm not going to get there. It doesn't mean that my genes and my environment are not going to genetically present themselves if I put them in the wrong place. What these studies are doing and what this information is starting to provide is a roadmap. We're making choices every day that we believe are in our best interest. We are making diet choices. We are making beverage choices. We are making diet and exercise choices. We are making environmental choices, where we live, what we expose ourselves to, what pesticides, what chemicals, what air we breathe, literally. We are making these decisions, and sometimes we're making them just unconsciously. But the reality is, if we take the time to understand what our genetic code is, what our genetic sequence is, and most importantly, get the genetic information and then make informed choices, at least at that point, even if you don't change, you know what you've done. You know what the risks are. I mean, there's still people out there, 15% of Americans smoke, knowing on the package it says it causes cancer. And I'm not judging people that smoke. I'm just telling you, I mean, the warning says this will cause cancer. It will cause throat, lung, and other forms of cancer, but yet people still choose to do it. Genetic information is the same thing. It is the future, though. It is where we're headed, and it is going to provide us the roadmap and providing us the information so that we can make a better informed choice with regard to how to handle our diet, lifestyle, and environmental choices to reduce our risk of disease. So really what it boils down to is simply that. Diet, lifestyle, environment equals health. This is consistent with what we talk about all the time at ID Life. Those diet and lifestyle and environmental choices are what are going to determine our health. And in fact, the diet and lifestyle choices will determine our nutritional gaps. They always have, they always will. In fact, it's consistent with the wonderful thing that we refer to as healthy living. Those diet and lifestyle choices and filling those nutritional gaps will help you get to the healthy living style that you're looking for. And if you don't fill those nutritional gaps and you continuously eat and do the things that you want to do, you're going to continuously get what your parents got. People look at their family history. My mom had heart disease, diabetes, etc., and they think, oh, that's why I have heart disease, diabetes, etc. The reality is, the reason why you got what your parents got is because you did what your parents did. If you do something different than what your parents did, you might not get what they got. It really, and that's very simplistic, but the reality is your medical history, specifically your family's medical history, is a crystal ball to what's going to happen in the future if you do exactly what they did. And hey, let's be real, that's where you learned how to eat. That's where you learned how to act. That's where you most likely chose the environment in which you currently live. If we make changes to those things, though, then we might get a different outcome. Genetics, same thing. The genetics gives us an information. They gives us the crystal ball. They give us the information we didn't know about ourselves so that we can make informed choices. But every day, people continuously ignore those and ignore that information and continue on about their lives, just waiting until something happens and then trying to react to it.